The dissolution of the Soviet Union in 1991 had a profound impact on various sectors, with science and technology experiencing some of the most significant disruptions. The USSR had been a global leader in fields like space exploration, nuclear research, and military technologies, but its collapse led to the abandonment or scaling back of many critical research projects. In space exploration, where the Soviet Union had once achieved remarkable milestones such as launching the first satellite, Sputnik, and sending the first human into space, Yuri Gagarin, the successor state Russia could no longer maintain the same level of ambition. Long-term space projects, including lunar missions and deep space exploration, were postponed or severely diminished due to funding cuts. Similarly, the highly advanced nuclear research programs, pivotal for both energy production and military applications, saw many of their projects terminated, while Russia struggled to maintain its leadership in these areas. Military technologies, a cornerstone of Soviet prowess, also faced severe setbacks. The collapse brought an abrupt end to the centralized funding that had driven cutting-edge research in fields like missile technology and electronic warfare. Many of these projects either ceased or were sold to other countries, marking the decline of what had once been a formidable force in military innovation. One of the most immediate and damaging consequences of the collapse was the brain drain. Scientists, engineers, and researchers, some of the most highly trained professionals in the world, left the former Soviet republics in large numbers. Economic instability, lack of resources, and uncertain career prospects forced many of these individuals to seek opportunities abroad, particularly in the US, Europe, and Israel. This migration significantly weakened scientific institutions in Russia and other post-Soviet states, particularly in specialized fields like theoretical physics and space science, while benefiting the scientific communities of the countries that welcomed this influx of talent. The dissolution also severed the strong collaborative ties that had existed between Soviet scientific institutes and universities. The vast network of research facilities that had once functioned in unison across the USSR was fragmented, leaving many institutions underfunded and isolated. Some had to close their doors, while others drastically downsized, unable to maintain the cooperative, large-scale research projects that had once flourished under Soviet rule. Technological development, particularly in computing and IT, stagnated. Although the USSR had been trying to build its own computer and software industries, it lagged far behind its Western counterparts. The collapse exacerbated this gap, as government-funded development initiatives were discontinued, leaving Russia and other post-Soviet states to struggle in catching up. Similarly, industries like aerospace, automotive engineering, and electronics manufacturing, once leading sectors, faced sharp declines due to reduced demand, loss of capital, and lack of coordination in the absence of centralized control. In addition to technological setbacks, environmental and scientific management projects initiated by the Soviet Union also suffered. Large-scale environmental management efforts, such as land reclamation, water management, and pollution control, were abandoned amid the economic chaos. This led to worsening environmental crises, such as the Aral Sea disaster, which deteriorated further without coordinated action. Nuclear safety became another major concern, as aging nuclear reactors, poorly managed and underfunded, posed significant risks. The prestige that the Soviet Union had built in international scientific circles, especially in physics, mathematics, and space sciences, was also eroded. Russia and other former Soviet republics lost much of their influence and prominence in global scientific discussions. The funding for international collaborations dwindled, further diminishing their role on the world stage. Moreover, the USSR's collapse led to a drastic reduction in funding for basic research. Under Soviet ideology, science and technology were heavily prioritized, with significant resources devoted to basic research, even when there was no immediate economic payoff. In the post-Soviet era, much of this funding disappeared, and research institutions had to shift their focus to applied research with direct commercial potential, leading to a reduction in long-term innovation and scientific discovery. Despite these immense challenges, some positive outcomes gradually emerged. The economic difficulties that Russia and other post-Soviet states faced spurred innovation through necessity, particularly in fields like aerospace and defense. Russia's space agency, Roscosmos, became a reliable partner for international space missions, such as the International Space Station, ISS, where Russian collaboration with Western space programs demonstrated a new era of scientific cooperation. Russian scientists also became more integrated into the global scientific community, leading to international collaborations that helped maintain a degree of scientific output. In short, the collapse of the Soviet Union caused a profound decline in science and technology, marked by brain drain, halted research, and the breakdown of collaborative networks. However, while the losses were significant, Russia and other former Soviet states have made efforts to rebuild and integrate into the global scientific community. Yet, they have not fully regained the scientific and technological heights of the Soviet era. We hope you find it enlightening. Do not forget to like and subscribe for more insightful contents, and we look forward to seeing you in next video.